This video. First is video.
First is the.
I was in the last year. And I don't know what it happened. I was glad, but
Thank you very much, and welcome to our launch event for the Andromeda product family. 15 months ago, I think I took one of the great decisions of my life. I took on the role of CEO of Enclustra and started to work back in Switzerland after staying in Asia for over 17 years. So my name is Philipp Echtold. I am now the CEO of Enclustra, and during the next 35 minutes, I'm happy to be part of the team that is presenting this new product family. We have with us SoM Jokar, his product engineer for electronics for standard platforms. He will showcase the new Andromeda product family. Mark Oberholzer, our VP Engineering, goes into the details of our x86-65. Roland Paul, he's going to jump over his shadow and give something away for free. Our VP Sales of Engineering. He doesn't do that many times. And actually we have Thorsten Trenz here, our long-term implementation partner and supporter of our design standards. And I'm especially delighted to give you Martin Heimlisser, our founder, who will be happy to answer any questions that you have regarding our technology. Well, we're all here to learn about Andromeda, and I have been given 75 seconds to introduce the company itself. So let's start the timer and talk about who we are. Well, we're not just any FPGA company. We are committed to pushing FPGA technology to new heights. We lead innovation, we lead design, and we lead industrialization of the world's most advanced FPGA applications. Our worldwide network of experts enables us to deliver cutting-edge FPGA expertise, and Enclustra's one-stop shop streamlines the development process and provides the tools to bring your ideas to life. We offer fastest turnaround time in the industry, and our offices in Zurich, Ulm, and Shenzhen are designed to provide you sales, design, and manufacturing services. Our team of talented and creative engineers provides cutting-edge FPGA expertise, while our highly skilled sales representatives in France, the UK, in Canada, and the United States are dedicated to support you in any question you might have. Industry-leading design expertise and fast turnaround time enables us to create cutting-edge FPGA technology and cutting-edge FPGA solutions with ease. If you choose Enclustra as FPGA technology partner, we can take our business and your business to the next level. And as such, almost in time, I give you now SoM Jokar, and I'm happy to hand over for the presentation of the Andromeda family.
All right, thank you, Philipp. Good. Hello, everybody. I'm very happy to be here today. My name is Samir. I'm a product manager at Enclustra. And yeah, product management is not just my job. That's also my hobby. That's what I do on the weekends and during my holidays. It's not true. This is what I like to do on my holidays. I like to travel the world, make YouTube videos. And yeah, these are quite recent. It's from January. I was visiting Thailand. This is an elephant kissing me. They told me it's a baby elephant, but I will check. Okay, I'm not here to take you on a journey with me on Earth, but I'm here to take you on a journey in the universe of Enclustra. As you know, we are here today to launch our new product family, Andromeda System-on-Module. And before I do that, I would like to introduce briefly what a SoM is. Probably a lot of you guys are familiar with it, but in the world of electronic system designs, FPGA System-on-Modules have been one of the most exciting developments. So an FPGA SoM is basically a compact circuit board that integrates the FPGA with memories, embedded processing core, DSP blocks, clocking, high-speed serial communication, and IOs interfaces. Due to their programmable nature, FPGA are a very compelling proposition for many different applications. To introduce Andromeda family properly, I would like to first give you an overview of our product portfolio so that you can understand better why Andromeda is our next generation product family. So there are different ways to look at our portfolio. One way is by looking at the core technology of the SoM, so the FPGA System-on-Chip. As of today, we have a large part of modules based on AMD Xilinx technology, but we are developing as well Intel and microchip modules. And we are certified partners with each of these vendors, and we evaluate to broaden our partnership and the technology base going forward. The other way to look at our portfolio is by product families or form factor. So what you see here is our NAS product family. You can see the front and the back side and some main specifications in the middle. Mars is one of our early and very successful product families with a form factor of 67.6 by 30 millimeter, 108 user IOs, and 4 MGTs at 5 gigabit per second. Then we have Mercury. It comes with different form factors, larger form factor, up to 294 IOs, and we have transceivers that reach 15 gigabit per second, up to 16 transceivers. To the Mercury family belong our most successful flagship products, like the X-Ray series and the newly introduced Mercury PolarFire series. And is it in this frame where we now introduce Andromeda? So as you can see, Andromeda comes in different form factors, and this way larger module. We have much larger FPGA system-on-chips, which means we are able to offer much more input-outputs, much more fast transceivers, and you can see the speed of the communication is now up to 28 gigabit per second. So with Andromeda, we are able to unlock a whole new spectrum of application thanks to these very powerful FPGA devices. We like to define Andromeda as Enclustra most scalable platform, and arguably one of the most scalable FPGA SoM platform on the market. Here we can see the 3 form factor characterized by larger devices and thus more resources, IOs, and fast MGTs. All form factors come with a memory with the error correction on the processing side, the PS side, and we have Samtec AMD 6 connectors, which are able to sustain 28 gigabit per second communication speed. On top of the PS memory, the larger form factor can provide up to 2 additional memory channels on the programmable logic. And yeah, not only this, Andromeda will also be the platform with new core technologies. So we are planning to introduce Versal technology, more Intel variations, and even other SoC modules. Good. As we just saw, there will be many different products in the Andromeda family. However, what we would like to launch today, our pilot platform is the XZU65 series. So let's learn more about it. So this is what we just saw in the video. this is the module. It comes in the L size of the three form factors I showed before. It's equipping a ZU7 ultra-scale plus system-on-chip with video codec in the C1156 package, speed grade 2 and industrial temperature range. That's temperature grade. The system provides 504,000 system logic cells, PS and PR dedicated memory channels, 24 MGTs, and 322 user IOs. This module is compatible with the Mercury SC1 baseboard, and this is possible thanks to this very simple adapter board. So it's very simple to integrate if you have already worked with our Mercury baseboards. And yeah, I guess you are probably all now thinking, wow, Andromeda is great. When can we have it? And yeah, Andromeda is ready. So is it right here? Is it available on our website? All the informations, and of course, it's available for all. Besides ZU65, this is our roadmap going forward this year. So today we are launching ZU65 7EV, 11G, the adapter board, the baseboard. Next quarter, we plan to have ZU90. This is the SoM in the L form factor with higher number of logic resources, IOs and MGTs. In the second half of the year, we will be working on other two series, especially in the small form factor with ZU30 and also on a new baseboard. And going into the next year, we will have the Versal, Intel, and the other SoM modules. And in analogy, the Andromeda Galaxy has about 1 trillion stars, and that's the number of products we will have in this family. And yet, is 1 trillion enough? No, we have another mission on Pluto. We like to call Pluto the SoM of the size of a coin. So this is a Swiss franc coin. This is the proportion with a €2 coin. So it's a very small module. It's 31 by 31 millimeter. And yet, on this 10 square centimeters, we are able to place an FPGA System-on-Chip, memory, USB PHY, Ethernet PHY, and up to 100 user IOs. This is possible because we have FPGA pads instead of connectors, but of course also thanks to Enclustra expertise in SoM design. And with that, we presented now a complete overview of our portfolio as well as the ongoing developments. I would like now to stop the astronomy lesson. I bring back the focus on Andromeda ZU65 and hand over to Mark, our VP Engineering. So, thank you.
Yeah, hello everyone. I'm Mark, VP Engineering of Enclustra, and yeah, welcome to my part of the presentation, where I talk about our low latency vision demo that's based on Andromeda ZU65. Now, I'm no YouTuber, but I'm a huge aviation enthusiast. So I don't know exactly why, I just like planes a lot. So this is why I occasionally visit air shows and take pictures there. So usually this happens on kind of an airfield. But for this picture here, I had to climb a 2,500 meter high mountain, bringing all my equipment with me, food and drinks, lenses, cameras. And then I got a bit surprised here by the very close flyby. I could not fit actually even one of them in my fully in my frame, but I swear there are other pictures where you can see a full plane. So although I think it was worth the effort to climb up there, getting there was not so easy. And if you're employing FPGA or SoC technology, this may not be an easy walk either. You're dealing with complex systems, complex development processes, and there is a steep learning curve if you're new to this technology. Enclustra's mission is to make this technology accessible and easy to use for everyone. One part of this is, of course, our SoM product portfolio, and another part of this is our design services team. That provides services from consulting to system design up to full turnkey system development, covering hardware, firmware, software design, basically the full stack of those kinds of systems. Now, the demo that I'm finally will start talking about is showcasing 3 different approaches to the same design problem, taking into account different business aspects. So what does this demo do? It does this.
Project schedule and are looking for engineering resources to assist you with your custom FPGA development project. Let's see how Enclustra FPGA design services can help you with those challenges. Do you need help with your FPGA design to minimize the project timeline, cost, and risk by accessing state-of-the-art FPGA know-how? Please visit our website, write a short email, or visit one of our in-person or online events.
So, as we just have seen, the demo does real-time edge detection on video data. In this showcase here, it was a pre-recorded video. The real demo over at our booth uses live video camera streams to do that. So what's the theory behind it? Since I'm from engineering, I need to talk about this a bit, right? So, no surprise here, we are calculating an output image for each input image by doing edge detection. And we do that pixel by pixel. So for example, if you want to calculate this pixel's grayscale value, we identify the corresponding pixel in the input image, and we apply the SoM operator, which is in this case a 3x3 matrix, to the direct surrounding of that pixel. And in detail, it means multiplying each pixel's value by the SoM operator's value and summing it all up. And we do that again for the second direction. So we do that for the horizontal direction, we do it for the vertical direction, and we combine those 2 values into the value of the output pixel. And of course, we do that for every pixel in the output image and for every image in the video stream. So what does that mean in terms of processing power? Here it comes, yes. So for 1 pixel, we need to do 12 multiply accumulate operations. It's 12 and a 9 because we have 3 zeros in each operator, so that we do not need to calculate anything. For the whole output image, of course, it's a 7x7 image in this very simple example. It's 49 times 12, 588. With 30 frames per second, we are reaching something like 17,000 multiply accumulate operations, which does not seem like a lot, but in real world, we're obviously operating on much larger images. So for HD resolution, we're around 5 billion multiply accumulate operations per second. And for 4K video, it's more than 40 billion. Now, for the experts in the room, a bit of small print here. So this is a very simple consideration. We did not take into effect the RGB to grayscale conversion, the combining of the 2 directions, edge effects, where we do not have all the pixel values available from the input image. And the most important thing, we did not exploit symmetry and separability in this calculation. So in the real world, we are not doing that many calculations, but the order of magnitude is the same. Now, how is the demo built in terms of hardware parts? The first thing, the basis, is our Mercury ST1 baseboard. And as Samir already said, to enable an Andromeda SoM on a Mercury baseboard, we need this adapter board, which is also available to you. Of course, the star of the show here, Andromeda XEDU65, is the heart of the system. We have an image sensor with some optics, which is connected through a MIPI CSI2 interface to the FPGA part. And we have a simple DisplayPort off-the-shelf monitor to show the result. Now, if we zoom into the Sync UltraScale device that is on the Andromeda XLU65, we see the programmable logic part on top, which is kind of the FPGA part, and we have the processing system on the bottom. And since the image sensor is connected to the FPGA part, we'll start with that. The first step is, of course, to have a VPCSI2 receiver in that FPGA that accepts data from the sensor. Next step is an image signal processing pipeline, which takes the raw data from the sensor and does like the delayering, color correction, everything that's required to get a nice image, high quality video image out of the raw sensor data. Then here's a video switch, which does not make much sense right now, but we will get there. And a frame buffer writer that writes full frames into the external DDR4 SRAM. At this point, we are able to receive image data from the sensor and store full video frames in the external memory. Now the processing systems comes into play. We're using a Linux operating system and the GStreamer framework for doing video operations in Linux. There is also some drivers, video for Linux 2 drivers included to configure the whole FPGA part. And we're using the DisplayPort peripheral that is already present in the Sync UltraScale Plus for actually displaying the image data on the external monitor. So at this point in time, we have built a very expensive cable. So we can just watch the video that the sensor shows. So there is no filtering yet. And that's how we add the filtering to this system. I talked about 3 different solutions. The first one is a pure software solution. It's implemented as a GStreamer plugin. And yeah, this is, of course, relatively simple and low development effort. The second option is the so-called HLS option. So we took the software, the code we wrote, and used it as an input into Xilinx's high-level synthesis tool. So this tool generates VHDL, synthesizable VHDL code out of C++ software, and is of course a very convenient and fast way to accelerate your software implementation by leveraging FPGA resources. And for the third option, we rolled back our sleeves and wrote very optimized VHDL by ourselves. All of those 3 options are displayed at our booth, where if you turn around, you can actually see the logo, so it's just around the corner. This is how the system looks. Now it's also clear why we need a video switch, right? So we can choose between the different options. So if we need to compare these 3 options by like the technical parameters, and I will do that afterwards also considering the development effort, we see for the software implementation, it's a 3x3 solo kernel. We do not use any of the FPGAs or PL part resources because it's a pure software solution. We reach 11 frames per second and we have a latency of 76 milliseconds. And this is just the SoM part. It's not glass to glass, it's just the SoM calculation. And we use almost 3 of the 4 available cores. So your processing system will not be able to do much more than this. For the HLS version that runs in the FPGA, we go to a 7x7 SoM kernel because we can, and it's more fun and gives the better quality image in the end. Of course, it uses some FPGA resources, 3,000 lookup tables, some block RAMs, some DSPs, not much, but it's also a very simple operation that we're doing. The demo runs on 30 frames per second with a full HD resolution. We will be able to do 4K at 60 frames per second as well. The latency through the SoM calculations is below 100 microseconds. So this is a huge step. So here you can talk about real-time Software solution, definitely not. And we also very clearly offload the CPU. So we almost, there's just Linux sitting there and doing some kind of task scheduling. So your processing system can do a lot of different things while the FPGA is calculating the solar filtering. The HDL implementation that we did manually has exactly the same performance, but does use a lot less of FPGA resources. The same amount of DSP slices and block RAMs, but lookup tables, we could reduce that by a factor of 4. Now to assess the whole thing, development effort, of course, for the software part, very low, but you get low performance and also low resource efficiency because you use almost all your processing power. For the HLS version, medium development effort, high performance, but also kind of a low resource efficiency because it's off by a factor of 4 compared to the optimum. And for the HDL part, there is a high development effort, but also a very high performance and a very high resource efficiency. So now what are the cases? When would you apply which version of that implementation? Software version is, of course, very helpful in a proof of concept phase, where you still play around, where you need to find out what should my system do, how can I implement it, but you do not yet need the full real-time performance. The HLS way is full performance and shortest time to market. So, but on the downside here, you use more resources, so you probably need to spend more money for a larger device in your system in the end. And the HDL version is the full performance at lowest system cost, but you have to invest a bit more development effort to get there. And as mentioned, those 3 options are showcased at our booth. Please visit us, also talk to our design services experts, so we would be happy to learn about your current or future endeavors in FPGA-based system design. So thank you very much for your attention. Now I'm handing over to Roland. He has some exciting news, I think.
Yeah, it's amazing, isn't it, to be part of such a team, being part of such a company, doing such great things. It's a great privilege to do something special tonight, to give away something for free, which is something that I'm, as a salesperson, cannot do so often, but I'm all the more excited. What I like to do on my free time, I like to be outdoors and do sports. And just last Sunday, I was doing a cross-country race in the Swiss mountains in the Engadin Valley. It's 44 kilometers, and it took me 2 hours and 44 minutes. So that's pretty okay. I'm pretty happy with that. There was about 12,500 people doing the same race. Yeah, and in the summer, I like to do mountain bike racing, and that's what I enjoy when I don't have to sit in the office. And I'm quite sure that for a lot of you guys, and ladies, it's the same. You don't like to sit in the office on your free time. You like to enjoy yourself. You like to enjoy your life. You don't like to debug a memory interface that you can just buy off the shelf. You don't like to rewrite your project schedule because your hardware design is delayed again. You don't like to have escalation calls with your customers because you have to explain them that they're not getting their product. So you want to spend your free time doing the stuff that you love and you enjoy. And that's why we have, at Enclustra, we have designed products that make your life easier and that let you enjoy your life. And yeah, one of these products was introduced today, and we want to give away designing kits today to make your life even more enjoyable and more fun. And for for being able to win one of the design kits, you have to fill out the form on the back of this brochure or catalog that most of you got, I think. And if there is somebody here that still wants to enter the raffle and wants to get a shot at 3 designing kits that we're giving away, this is basically your last chance. Fill it out and put it into this box here, and you can be part of the winning team. To give you some more seconds to fill that out, I also want to talk briefly about the brochure here, because in the middle of the brochure, we have put some product ideas. So some ideas of products that we're thinking about designing and building in the future. So if you see something in there that you think, this is exactly what I wanted, or if you don't find what you want in here, then please contact us and we can create a product for you. We have done that more than once, and we like to do that. We like to create products which make our customers happy. And then I also want to speak briefly about this very cool adapter kit. So this adapter is part of the designing kit you can win today, but you can also get this separately. And this adapter board will actually enable you, if you already have a Mercury Plus baseboard with an Enclustra module in your system, to use this adapter board and to try out our Andromeda module in your existing hardware. So if you need an upgrade of your existing hardware, maybe a little bit more power, use this adapter board and you can plug in our newest form factor. So now your last chance is over. So yes, that's the last. Thank you very much. So now we still have one coming. Okay, I'll give you a second. Oh, 2 more. That's great. And maybe in the meantime, I can ask the designing kits to be brought to the front. There should be 3 designing kits ready. Yes, maybe here's the first one. Okay. So this is our X65 design kit. It comes in a nice case. You can also take that along and walk through the streets and just feel like you're the big guy. And if you open this designing kit, you will find very important accessories. So first, you find an Enclustra beer. This is our home-brewed beer. It's brewed in Zurich at our headquarters. You'll find cable and adapter board and the baseboard, and then the Andromeda module, of course. So everything should be in here. If you're missing something, come back to us and tell us. We'll get it for you. So this is the X65 designing kit. We have one of those to give away. And then we have also 2 Mars XU3 designing kits. These are quite chic because they're smaller than the X65 designing kit. They are based on our Mars XU3, on our Mars smaller module. And so 2 people will get an XU3 designing kit. So, and this is now really where I close the raffle. So has everybody been able to enter his card? So this is, okay, now it's done. All right. Now I get to draw the cards, this is really amazing. So how do I do that? Probably I shouldn't look, huh? So probably. So let's get somebody for an XU3 designing kit. Okay. So this is where you hope you win, but then again you hope you don't win because you want the X65 designing kit. But let's go and oh, there's a lot of cards. Must be about 100. Really? Are you that many? Okay, so let me check. So there was a question about what LUT stands for. Does anybody know what LUT stands for? Yeah. Lookup table, yes, very good. So we have here a Maurizio Gasti. Maurizio, you're the winner! Congratulations! Please come up. Yeah, that's difficult, right? Okay, so I can hand over to you this formidable Mars X3 design kit, and of course we need a photo. Where's the photographer? Can you please come up here? And you can hold it, and I will smile. Very good, very good. Congratulations, Maurizio. Hey, I hope you have much fun with it. Okay, now we go for the second X3 designing kit. And I'll really try to make this fair and pick somebody I like. Okay. Again, I have to check. The term look stands for lookup table. So, oh, that's a difficult name. Akhenaton Botzenberg from INEC. Are you here, Akhenaton? Hello? Yeah, you have to be present to win. Sorry. Oof. That's too bad. I feel really sorry for Akhenaton. Can we send him at least some chocolate or something? You sure you're not here? Maybe you want to change your name now? Change it to Akhenaton Bottenberg? So, no, sorry. Okay, sorry, Akhenaton. That's very, very, very sad. So, then you give another shot. Okay, lookup table is right. The next winner is Fatih Dulgarolu. Fatih, are you here? Oh, I cannot feel more sorry than I already feel, so, okay. I think I do something wrong here. Can maybe Marcel, you have to help me. Okay. No, you said if you're from Enclustra, you cannot join the raffle. I mean, sorry, if you're from Enclustra? Okay. Did we not say that? Maybe we didn't. Oh, okay, I feel sorry again for you. If you're from Enclustra. Okay. Now, okay, we have a Stanislav Kneisel. Okay. Okay. Tobias Wahl from the University of Würzburg. Congratulations. Würzburg, huh? Würzburg. Okay, super. Okay, that's great. So I can present you with the formidable Mars X3 designing kit. Congratulations. And now we come to the final and ultimate giveaway, which is the XU65 designing kit. And now it's getting really, really tough if you're not here. I tell you, you're going to be so sorry if you're not here. But I hope you're here. So, it's a Gaetan Vasile. Are you here? Oh yeah. Yeah, I said it. Sorry. Very sorry. Very, very, very sorry. Oh. Okay, Igor Peroka. He goes. Okay, we'll make this much faster now. Robert Miller. Is Robert here? Robert Miller. Anybody, maybe a colleague from Robert here? A friend? Somebody who wants to become a friend of Robert? We should have told the people they must be here to get the win. Okay. Balat. Helmut. Okay. Please. Thomas Juncker. Is Thomas here? Thomas Juncker. Okay. I know this guy. Igor from RSIS. Hey! We have a winner! Very good. So, this is your grand prize, the X65 designing kit. And we'll make a winner's photo. Yes. Yeah, you're welcome. Have fun with it. So this was tough. This was hard work. So I think I need a drink now. What about you? I think we should celebrate now. This is a great moment for us. This is a great moment for Enclustra that we can release this new form factor, Andromeda, and we're really excited to celebrate with you now. Please follow us on LinkedIn. I was told that this is actually mandatory to get a free beer. If you can follow us on LinkedIn, if you don't do it, yeah, we'll probably let you get away with it. But please try anyway. Follow us on LinkedIn, and then please enjoy with us. And thank you to the whole team. Thank you for everybody preparing. Thank you for everybody spending time with us today. It's great to design, to create something together with you, and that's what we want to do in the future. So thank you very much. So enjoy.